All right, review of chapter 1. Let's see how far we can get. 1.2 was on points, lines, and planes, and there was a lot of naming and notation in that. So our first problems here say true or false or short answer and explain your answer. So that's going to be definitions and postulates that help us do that. We are asked point A, D, and F are collinear. So the first thing I'm going to do is find point A, point D, and point F. I know collinear means a line, so no. These are not on a line. All right, next is line AC and line FE are coplanar. Coplanar means in the same plane. So once again, no, because these are not in the same plane. One is in the plane that makes up the front, and one is in the plane that makes up the back. All right, points A, B, and E are coplanar. So there's A, B, E. Yes, and that's an easy one because 3 points make a plane. And plane ABE, so let's see here, ABE, we just marked those. So I'll get the lightly shade plane ABE and plane CFD. Let's find CFD. CFD is in the back there. Intersect at, well, what do we know about planes intersecting? We know that planes intersect in a line. So let's find that line. And that line is right here where the two meet. They intersect at line, and make sure you notate it properly, AD or DA. All right, that was fun. 1.3 was on measuring segments. This is where we learned about the segment addition postulate and congruent and midpoint and bisect, all of those good words. So let's see what's first on the list here. Okay, we are told that if length, right, we read that as length, JK is 48. First thing I do is I label my graph. I know that is 48 units long there. And length of JH is 4x minus 15, and length of HK is 2x plus 3. I want to find the values of x, the length of JH, and the length of HK. All right. Well, I don't have anything congruent. I don't have any midpoints. So what I'm looking at here is the segment addition postulate that says the length of JH plus the length of HK is going to equal the length of JK. And then I'm going to substitute. So 4x minus 15 plus 2x plus 3 equals JK. I marked as 48. And I just combine my terms. 6x minus 12 equals 48. Add 12 to both sides. 6x equals 60. Oh, that's a nice number. So x equals 10. That was one of the things I was supposed to find. All right. Then I'm asked to find the length of JH. So what do I know about JH? I know JH is 4x minus 15, so I substitute 10 minus 15. So that equals 40 minus 15. Length of JH equals 25 units. We aren't given any units, so we just use units. And the length of HK, now there's a couple ways I could do this. I know that the total length is 48. So I could do JK minus JH, which would equal HK, right? So 48 minus 25 would give me the length of HK is 23 units. Or I could just substitute in. I know that HK is 2x, which is 10 plus 3, and equals 20 plus 3. So HK equals 23 units. Either way, it's the same thing. So make good choices. Pay attention. Think about what you're doing. I think the 48 minus 25 is a lot faster, but you have to understand that, and you could come up here and label it. You could label this 25, and then you would see that you could use 48 minus 25 to get 23. You can also substitute in. That works. All right, so what's next? Oh, I see an important word here to us. Given y is the midpoint, I immediately know I've got two congruent somethings. So let's see. Let's find y. Y is the midpoint of segment xz. So it's this whole thing. I immediately, once I read midpoint, mark those segments congruent, because that is what midpoint means. Two congruent pieces. All right. Y is the midpoint of segment xz. Took care of that. Now I start labeling. xy is 2x minus 1, yz minus 4x plus 23. And I want to find the length of xz. So that would be the whole thing. Well, what I know here is I've got definition of midpoint makes them congruent, and definition of congruent makes them equal. So I have an equation. I know that 2x, oh, hold on, we should do this properly. I know that the length of xy, segment xy, is congruent to segment yz. Therefore, the length of xy equals the length of yz. Therefore, 2x minus 1 equals minus 4x plus 23. Add 4x to both sides. I get 6x minus 1 equals 23. Add 1 to both sides. 6x equals 24. Divide by 6. And x equals 4. All right, and then I want xz. So what I'm going to do is I'm going to find one of these pieces. Let's find the length of xy. So 2 times 4 minus 1. The length of xy, this is 8 minus 1. So the length of xy equals 7 units. And I know this measures 7 units. So what else do I know? I know this measures 7 units. And I know that the length of xz equals the length of xy plus the length of yz, which is 7 plus 7. The length of xz equals 14 units. Now, we also could have said, well, yz, length of yz equals a negative 4 times x, which is 4 plus 23. So that equals a negative 16 plus 23. And so we know that the length of yz, 23 minus 16, is 7 units. So you can substitute in, or you can be smart about it and say they are congruent, therefore they have equal measure. Once you find one, you know both. Okay, last problem on this page. We're moving right along. This says if the length of BC is 12, so I'm going to come over here and look at my diagram. I know that measures 12. And do you see anything else going on here? I do. The length of CD is 12 as well, because they are congruent. And I'm told that the length of CE, let's find CE, that goes from here to here, is 15. I want to know the length of DE. Well, the length of DE is just the length of CE minus CD, which is 15 minus 12, which is 3 units. All right, 12 plus 3 is 15. Notice when you label it on the diagram, it's really pretty obvious what's going on. Draw, 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 label, label, label. All right, next problem. If the length of AC, so let's find AC here, that's 5x minus 16, and the length of CF is 2x minus 4, then find the value of x. Well, once again, I've got congruent segments, which means their lengths are equal. So I can just do 5x minus 16 equals 2x minus 4. Subtract 2x, just do my opposite operations. Both sides, minus 16 is negative 4. Add 16 to both sides. 3x equals 12. And x equals 4. And then we could go back in and substitute our x in and find whatever we wanted. Once we found one, we would automatically know the other one because they are congruent. Well, that went pretty nicely. All right, let's look at the next section. 1.7. This was our coordinate plane, and anytime you see coordinate plane, you know that you're going to be using the midpoint formula and the distance formula, and or. All right, segment QT has the given endpoints. We want the coordinates of the midpoint. So I know that the midpoint can be found at x1 plus x2 over 2, y1 plus y2 over 2. So I know that I have to label my points x1, y1, x2, y2. See how fast that was? That half a second there makes this so much easier. Negative 7 minus 6 divided by 2. Negative 4 minus 10 divided by 2. These are xy coordinates. So that is what? Is that right? Oh, plus. That didn't look right. These are both plus. See, that's why we write our formula, so you can look back at it and say, what did I do wrong? So this is negative 1 over 2 and 6 over 2. So M, our midpoint, is at negative 1/2, 3. And anytime you see coordinates, the word coordinate, you know you are looking for an XY point. All right. 1.8, perimeter, circumference, and area. We are supposed to find the perimeter of a triangle with the given vertices. All right, let's start plotting. Negative 2, this is point A, negative 1, negative 2. Point B, 2, 3. B is at 2, 3. C, 2, negative 2. C is at 2, negative 2. There's our triangle. All right, to find perimeter, we know perimeter means that we are finding the sum of all of the lengths of the sides. And so I know I have formulas to do that. I'm looking for the distance formula. And I have a horizontal line here that goes from negative 1 to positive 2. So I know that the length of AC is the absolute value of -1 minus -2. That makes plus plus, which is the absolute value of -1 plus 2 is just 1. So the length of AC, 1 unit. And then I have a vertical line here that goes from 3 to 2. That's not right. What am I doing wrong here? I know what I'm doing wrong. Didn't write my formula. -1 minus a +2. It's not -2. So this is the absolute value of -3. There we go. Do the math properly and it all works out nicely. Okay, so the length of BC equals the absolute value of a 3 minus, and this is -2, 3 minus -2, this time a negative does mean plus plus, so that's the absolute value of 5. Don't put that there, move it down there. So the length of BC is 5 units. Okay, I have 2 of my pieces. All right, and now I'm looking at AB. So I know that A is at -1, -2, and B is at 2, 3, and I know I'm going to need my distance formula to find the length of AB, which I know is my square root thingy, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I know I need to label x1, y1, x2, y2. And that little half a second there makes sure that I keep everything in order. So square root x2 is 2 minus x1 is a -1. That goes squared plus y2. 3 minus -2 quantity squared. These are plus plus, so that's 3 squared. This is plus plus. 5 squared, so that equals 9 plus 25, and that equals the square root of 34, and the square root of 34 is, if we round to the nearest tenth, 5.8 units. So now I have all 3 pieces. I know that perimeter is the sum of all of my sides. 3 plus 5 plus 5.8 equals, the perimeter is 13.8 units. Which seems about right. All right, next problem. Find the area of the figure, round to the nearest tenth if needed. Okay, well, it's not a common figure. There's a couple of ways I can do this. I could either cut those off and do 3 separate pieces, right? Piece 1 plus piece 2 plus piece 3, that would be easy enough. Or what if I made it an entire piece and then subtracted out that piece? So we could do it both ways. The first one, if I cut those there, piece 1 is a rectangle, and I know these are marked congruent, so I know all of these are 5 meters. And 20 minus 5 minus 5 would make this one 10 here. And 18 minus 5 would make this one 13 here. So this is 20 by 13. And then I have 2 little ones that are 5 by 5, both of them. So 1, 2, and 3, I know that area is base times area of a rectangle is base times height. So area 1 is 13 times 20, or 20 times 13. And that is 260 meters squared. I know that the area of number 2 here is 5 times 5, which is 25 meters squared. And area 3 is 5 times 5, which is 25 meters squared. So here, area total is area 1 plus area 2 plus area 3 is 260 plus 25 plus 25 is 310 meters squared. Okay, what if we cut that piece out instead? Then I would have a rectangle that is 20 by 18. Okay, and I would have another one down here at the bottom that is 5 by 10. And so the area of my first one here, we'll call this one number 4 and this one number 5, so we don't mix them up. So area number 4 is 18 times 20, which is 360 meters squared, and area 5 is 10 times 5, which is 50 meters squared. Now this time, area total equals area 4 minus area 5, right? Because we're cutting out this piece down here. And so that equals 360 minus 50. And guess what? We get 310 meters squared again. So it doesn't matter whether we cut the two pieces off the bottom, the two little squares off the bottom, or we cut the one rectangle out of the bottom. We're going to get the same answer. All right, last problem in 1.8. Given circle M has a diameter of 12 centimeters. That means we know the radius is just diameter divided by 2 is 6 centimeters. Find the circumference and the area in terms of pi. In terms of pi and to the nearest tenth. So we're doing both. All right, so we know circumference is pi d or 2 pi r. We have the information for both, which is just pi times 12. So our circumference equals 12 pi centimeters, just a length, it's perimeter. And then I put that into my calculator and get 37.699. So that's 37.7 centimeters. There is in terms of pi and to the nearest tenth. I know that area of a circle is pi r squared. So that's pi, and my radius is 6 squared. So area is 36 pi centimeters squared. Area is always squared. Or I can put that into my calculator, and 36 times pi gives me 113.097. So that's 113.1 centimeters squared. If it says in terms of pi, you don't put pi in the calculator. If it says round to the nearest tenth, you do put pi in the calculator. All right, I feel like we can finish the bottom of this page. So 1.4. 1.4 was on measuring angles. This is where we started angles. And our first question is, blank is the angle bisector of blank. Well, let's go find an angle bisector. Look, I have congruent marks. That tells me that something is being bisected, right? Cut in half. And that would be who's being cut in half? Angle BCA, and who is cutting angle BCA in half? Why, that would be segment, it's got two endpoints, CG. All right, what's next? Given the measure of angle BCG, okay, BCG right there is 60 degrees. What is the measure of angle BCA? Well, as soon as I mark that 60 degrees, I can mark that 60 degrees. So I know that it's just 60 plus 60 is 120 degrees. Congruent is awesome. All right, what's next? Given angle PQS and PQR are adjacent angles. All right, looks like I'm going to have to draw something. So I need to draw some adjacent angles. So I usually draw them big enough that I have some space to work in them. Okay, now we need to label these. So what is common? I know Q is the vertex of both of them. And what else is common? I see PQ in both of these. So I know this has to be P. So I have PQS and PQR. Learn to read the names, and it will tell you a whole bunch of information about what's going on. So I drew adjacent angles. That's all I know about them. And we are told that the measure, PQR, this one is 4x plus 7. And PQS is 7x minus 4. Oh, and some new information. RQS, the measure of RQS, oh, that's this entire thing, is 36 degrees. As soon as I do that, I see angle addition postulate. Angle addition postulate. But all we're supposed to do is draw and label a diagram, which we did. I still see angle addition postulate. All right, well, that actually wasn't too bad. Let's go on to 1.5. Let's see how far we can go here. Maybe we can finish the whole thing. Rewrite each statement so that it is true. Okay, ray LJ and ray TJ are opposite rays. One thing I know about opposite rays is they have a common endpoint, and these do not. Remember, our endpoints at the beginning. So this would need to be ray JL and ray JT. J is common to both. It needs to be at the beginning. Okay, what's next? The intersection of two planes is a point. I know that when planes intersect, it is always at a line. And angles that form a linear pair are complementary. What do we know about a linear pair? We know linear pair looks like that, so that would be supplementary, not complementary. And supplementary angles are congruent. Well, they might be, but it's not a guarantee. Who do we know that's always congruent? Vertical angles are always congruent. There we go. All right, next, name two angles that form a linear pair. Well, just we said a few seconds ago, linear pair looks like that. I see 4 of them. We've got this line, right? And we've got this one on top, and we've got this one on the bottom. I don't really feel like naming all of them, so let's just name the ones that are on top. Angle APC and angle, we're using this line, so APC and angle BPC. All right, if we didn't use that line, we always could have used this line here. And we have ones on the right that go this way and ones on the left that go this way. I'm just going to name 2 of them, angle CPA. So if I'm going this direction, it's this here and this here. That's an A. And angle APD. And I could name, there's actually 4 sets of them there. We're only asked to name 2 angles. We're only asked to name 1. I went so far as to name 2. All right, name a pair of vertical angles. Well, we have them here and we have them here. So anytime we have lines that intersect, we have vertical angles, and in case you haven't noticed, we have linear pairs as well. So angle APD and angle CPB and angle APC and angle DPB. Vertical angles are easy to see. You're going to end up liking them. Okay, next problem. The measure of angle BDJ, so that's this right here, BDJ, is 7y plus 2. And the measure of angle JDR, that's this guy right here, is 2y plus 7. I want to know the measure of angle KDJ. We need to put 2 on somebody. Let's put 2 on this one. Why would I do that? What else do I see there? See that. That guy is orange as well. Okay. And what other important point do I see? We have a right angle. What does that mean to us? That means 90 degrees. And we are trying to find this angle right here. Put 3 of them on there. There's 3 there. Okay, we are trying to find that angle in the middle. Well, I am going to say that the measure of angle BDJ, that's my blue one, plus the measure of angle JDR, my orange one, is going to equal 90 degrees because we have a right angle there. So now I'm going to substitute 7y plus 2 plus 2y plus 7 equals 90. Okay, 9y plus 9 equals 90 minus 9. Both sides, 9y equals 81 divided by 9. Y equals 9. Now, there's a lot of different things I can do. I could find my blue angle and subtract my orange angle, or I could find my orange angle and subtract 2 orange angles from 90, which is how I think I'm going to do it. So we could find blue and subtract orange, so we'd have to find blue and orange, or I can just find orange, and I know that, what is this? The measure of angle, nope, gotta change color here. The measure of angle JDR is 2 times 9, that's my y, plus 7, so that's 18 plus 7. The measure of angle JDR, crossing all of those, is 25 degrees. So what I'm going to do is I'm going to label this 25 degrees, and what does that let me do? That lets me label this 25 degrees as well, because those 2 angles are marked congruent. And then I am going to say that the measure of angle KDJ, which is what we're supposed to find, equals 90 minus 2 times the measure of angle JDR. Right? Because there's 2 of them. I'm subtracting 2 of them. To get green, I subtract 2 oranges. So that is just 90 minus 2 times 25, that's 90, which is 90 minus 50. So the measure of angle KDJ is 40 degrees. And like I said, we could have found blue and orange and just subtracted. Let's look at blue here. 7, if I put a 9 in there for y, that would equal 63 plus 2 is 65 degrees. What's 65? 65 minus 25. Green would be 40 degrees. So any way you do it, you're going to get the same answer. All right. Ooh, another problem to draw. Ray SQ bisects angle RST. Bisects. What do I do with bisects? Two congruent. So I need, start with the second half, start with who is being affected. And again, I like to draw my angles big enough. That's a little too much there. My angles big enough to deal with and label. And so this is angle RST. Okay, and I know that ray SQ, so that's Q, bisects, so I'm automatically marking those two angles congruent. Definition of bisect. Okay, and then QST, measure of QST is 2x plus 18, and RST, measure of angle RST is 6x minus 2. And what do I know about these? Congruent means equal. So I know that angle RSQ is congruent to angle QST. So the measure of angle RSQ equals the measure of angle QST. That's definition of bisect and definition of congruence. And then I substitute 6x minus 2 equals 2x plus 18. Subtract 2x from both sides. 4x minus 2 equals 18. Add 2 to both sides. 4x equals 20. Divide by 2, or 4. Sorry. X equals 5. And I want to find, what am I trying to find? RSQ. So the measure of angle RSQ, I simply substitute in 5, is 6 times 5 minus 2. That's 30 minus 2. So the measure of angle RSQ equals 28 degrees. So I could go to my diagram and label this 28 degrees. And if I do that, what else can I do? That's 28 degrees as well. They are congruent. Congruent means equal measure. Oh, hey, I think we can finish this all in one shot. All right. Angle 1 and angle 2 are supplementary angles. What do we know about supplementary angles? What does that mean to us? 180 degrees. So I am going to draw supplementary angles. And you can go right or left. And supplementary means that right there. And let's see, we've got angle 1 and angle 2. Angle 1 is 4y plus 7. Angle 2 is 9y plus 4. Supplementary tells me that I can do 4y plus 7 plus 9y plus 4 equals 180 degrees. Actually, let's do this properly. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. That is definition of supplementary. So now I can substitute 4y plus 7 plus 9y plus 4 equals 180. 13y plus 11 equals 180 minus 11. 13y equals 169. That's convenient. One of the few numbers divisible by 13. Y equals 13. And the measure of angle 2, how do I find that? Well, then change colors. Measure of angle 2 is 9 times y, which is 13, plus 4, 91. Oh, we're doing so well here. $117. Is that right? 90 plus 27. Yeah, that's 117 plus 4. All right, back on track. The measure of angle 2 is 121 degrees. So we could label that here 121 degrees. Is that right? 9y plus 4. Yeah. So 121 degrees. And that would mean we could find this one over here, angle 1. We would just do 180 minus 121. So 60, 59 degrees. If we wanted. We weren't asked to, but we could anyway. All right. The last one. Angle ABC and angle DBC are a linear pair. There's our key word. We know what a linear pair looks like. Are a linear pair. And I know that linear pair means supplementary. Okay, so we need to do some labeling. Angle ABC, who's common to both? B. So let's label. No, come back. All right, so let's label, before we get all excited here. Point B is common to both. That has to be the vertex. So here is A, B, C, and D, B, C. B and C are common to both. That has to be the common side. And this is 180 degrees. Color is good. Geometry is easier in color. All right, now what else are we told? Angle DBC is 20 degrees less than. So less than means minus, and it always goes after something. So I'm subtracting 20 from something. What am I subtracting 20 from? 3 times the measure of my other angle. So it's 3 times whatever this angle measures. Well, what does this angle measure? I don't know. When we say I don't know in math, that means X. But I know this one is 3 times that minus 20. All right. All we had to do was draw and label a diagram. Well, I think we did really well. Make sure that you study your vocabulary. Make sure that you study your postulates and theorems. Use your big packet, your best friend. It will help you out if you need to draw pictures in there. There's space for you to make notes at the bottom to write down your definitions, like definition of midpoint, bisect, congruent, complement, supplement. And all of our postulates are in there. So if you want to draw a little diagram of what a linear pair looks like next to the linear pair postulate, that would be a really good idea. All right, those problems went pretty smoothly. I hope they go as well for you on the test.